Hello, everyone. I am Emad Ehsan. I am a Google developer expert. And the session has changed. So we are talking about AI and large language models. But if you are even a slightly better programmer and have not worked with AI, you do not need to leave. It is going to be really easy. And so I am originally from Pakistan, and I am a senior software engineer at Bayer in Warsaw and Berlin. I go back and forth. And today we'll be looking at how we can use Google's PaLM large language model to build a search engine chatbot. So you might have seen the sudden rise of ChatGPT recently, and not recently, over a year, and the fast pace at which the industry has changed completely. So it also brings with it some negative aspects. For example, a lot of programmers are now worried that our jobs might be taken over by AI. So if you have had that fear, can you please raise your hand? Okay, only one guy. I see. Anyways, can we start with a quick show of hands? Those of you who are students? Awesome. And junior engineers? Senior engineers? OK. And any non-technical people? So we are all technical, and even if you are at the start of your university degree, you will be able to follow what we are talking about today. Because what large language models have done recently, especially through the help of open source movement, is that they have democratized the access to these big pre-trained models, which are usually not available to smaller companies, especially individuals, because they require a lot of investment in resources, GPUs to train them, and scientists as well. So let's start with the basics. What is a large language model? Anybody would like to take a guess? By the way, if you are not comfortable speaking in English, we can probably use translation as well. Just raise your hand. And I'd like this session to be as interactive as possible. Yeah, please.
Maybe it's the next level of NLPs? Maybe.
Yep. It's a very good guess. So large language models are, so at a very basic level, large language models are very sophisticated autocomplete. You give them an input, and they come up with the highest probable text that should follow. So for example, in this case, roses, you enter roses are red, and this is the most likely output that the model has seen in the data set that it is trained on. And this is also what I have also mostly seen, what follows, roses are red. Same goes for code. If the model has been trained on a corpus of code, then given this input, it sometimes outputs this. And we'll see how we can control what it will output on recurrent calls. OK, so these large language models are extremely large. So as you mentioned, in NLP, we have had these classic problems of entity extraction. So what is inside the sentence that we have given it? So entities could be dog, horse, table. So in order to recognize what is an entity and what is a useless part of a sentence, for example, this is, so the word this is not very helpful. You want to extract entities, NLP algorithms have been doing so. So for example, initially we have had recurrent neural networks, then we had large short-term memory, LSTMs, and then came transformers that have revolutionized the whole industry. If these things are passing above your head, you can ignore them, but we'll see how we can actually start using them. But these are the use cases that you might have seen or will see in your future. So when you go work in the industry, So semantic analysis is when you want to classify text as negative or positive, violent or dangerous. Translation, obviously, you must have seen. So do you understand it? Okay. Okay. Anybody who doesn't get it, please raise your hand. Those who get it. Okay. Anyways, whether you understand it or not, the large language model is able to comprehend. So this is a simple dad joke, and so the model is, so if you pass this to a model and ask it to explain what is in the joke, it is able to comprehend the logic behind how it is the way it is. So these models are also very good at coming up with creative outputs. So you want to plan a trip, or you need ideas for a project, or you are looking, so for example, I am new to Istanbul, and I arrived last night, and tonight I'll be asking the LLMs to give me the best places to eat in Istanbul and the places to visit. So now I do not have to go through hundreds of websites to find the suggestions. And LLMs can give me a very good itinerary. I've always struggled with pronouncing that word. So LLMs let us prototype really fast. This is another thing. So if you work on any natural language processing project or any other machine learning project, you will see that you will it requires a lot of training data, and that is a lot of a big upfront investment. And so not only do you have to gather that data, then you have to refine it, and then you are able to train it. But with LLMs, these large language models can help you generate synthetic data for your models. So judging by the silence in the audience, I want to ask once again, so now what do we understand about LLMs? What is a large language model? Random guesses are fine. Anybody? Yeah, please.
There are language models that have been trained on massive data sets. They can comprehend a variety of different paragraphs.
Exactly. So trained on large machine learning models that are trained on big corpus of data, and they can perform a variety of tasks. And one thing, so have anybody heard of prompt engineering? Yes, please. Exactly. But it is actually the art of doing that. So when you are interacting with ChatGPT or Google Bard or any other language model, so the way you can make the model to give you best desired output, that has been termed as prompt engineering or prompt designing, and it has a few different types. So for example, zero-shot prompting is where you simply ask a question and it responds. One-shot prompting is where you give it an example. For example, I want to map Istanbul to Turkey. So what would Berlin map to? So the model responds. That is where the model would respond, and it will understand the connection between Istanbul and Turkey, and then it will try to figure out what Berlin maps to. So that is called one-shot prompting. There are other types like multi-shot prompting. So this is just something that I wanted to touch. But how can we actually utilize the power of large language models in building applications? So a lot of you are students, and when you will be graduating, I believe the industry will have shifted more towards these type of products, and you will be working on building these things. So by integrating these large models into your application, you can build automated customer service, like Usually you call the customer service, the person does not know how to resolve your problem, but LLMs are very efficient in that aspect. And we are already seeing them taking over some of the jobs of customer service. We have seen, with the rise of ChatGPT, we have seen the jobs of content writers and SEO experts already vanished. So those of you who do not agree with me that these models are going to take programmers' job as well, you just need to extrapolate what's happening. You don't agree? I like that. So these are some of the products. And let's see if we can build some of these examples. But first, let's look at embeddings. This is slightly technical, the basics that you should know. Can anybody explain embeddings? Yeah, please. Vectorized words. So embeddings are, so usually these large models are essentially matrix multiplication. They are simply doing 2x plus 3y, but at a very large scale, billions of variables. And they do not understand the words that we input. So if you input an English sentence or a Turkish one, how do these models know what is mentioned in the sentence? So the way for them to understand it is we convert these inputs into numbers. We map them to numbers, and they could be at word level, and sometimes we convert whole paragraph into a few numbers, and they can be huge. But if you reduce the dimensions of those numbers and try to plot them, you can visualize them. So embeddings are embeddings essentially capture the concept behind the entities mentioned in your data set. So for example, if your data set contained words that, sentences that can mention these countries and their cities, and man, woman, king, queen, these all words appeared in sentences. These embeddings would capture in such a way that when you plot them, the similar concepts would be sort of clustered together so that they capture the meaning of what those entities are. So what man is to woman is king is to queen. What Canada is to Ottawa, China is to Beijing. So this is how the embeddings, they are not only the number representation of your input text, but also they capture semantic understanding. Retrieval augmented generation. This is something that has has gotten really popular. It is a way of architecting your system design that includes LLMs. So if any of you will, soon when you graduate, you will be applying for Google, Microsoft, and these big tech companies, and you will be preparing for your system design interviews. And now those designs also include large language models. So in the simplest form, let's say we have a pre-trained large language model. For example, Facebook has released Llama. We start using that in our product. Have you heard of hallucination? Yes, please. Anybody want to explain? Sure. Sorry?
Starts to talk out of context.
Yep. Yes.
Unknown information that produced by the LLMs. Doesn't exist.
Yes.
When a language model produces coherent text that actually implies something which is not true.
Yes.
It's some type of like interesting ambitions from our concept.
Mm-hmm.
So it's maybe related to something like that for conscious, for the training.
Mm-hmm. Yes.
Maybe redundant data, it's present
Yes, you can say that. So hallucination is actually, it's simply when the model gives output that is not true. It makes perfect sense when you read it, but if you don't know the fact, the true information, you can believe that it's probably true. So that's called hallucination, and in order to avoid it, we provide the large language model with a source of truth, so that it can rely on that information as to be true, and when it responds to our question, it will make sure that it is responding a factual thing. So don't be scared by this. This is the architecture that you'll be seeing a lot if you work on system design or backend or even front end. You will see some part of it. So what we are doing is that what we saw here, this part, the source of truth, in order to provide it to LLM and integrate LLM to our product, we have to go through this. So we have some documents. They can be, for example, your company's internal private documentation. They can be hospital records that are private, that cannot be made available on Google, so search engine does not have access to them. So, or they could be your personal diary, journal, that information that is private only to you, but you want to make it searchable so that when you ask the question, you responded. So what did I write in my journal on 26th of January when I was, 26th of November when I was in Istanbul? So the model would be able to pick it up. How? So we have to facilitate it first. So we divide our documents into chunks. That's because the large language models have this context length limit. So these models, it can only absorb information that goes up to a certain limit. So you must have heard of 8,000 words or tokens. OpenAI recently introduced 128K tokens. So it can now absorb a whole book as information, as source of truth. So when we are developing this, our search engine chatbot for our private journal, what we do is we divide the documents into smaller parts, and we convert them into embeddings. So if you remember, the model cannot cannot work on normal text. It has to work on those numerical numbers that represent the text. One thing important here is that different models work with different embeddings. So for example, the embeddings we saw here, so with OpenAI's ChatGPT model, it's possible that Madrid is above Spain. So, but for Google's PaLM language model, it is below. So if you obtain embeddings from OpenAI, they would not work with Google's LLM. So you have to make sure the language model you want to use, you only obtain embeddings for your data from that model. So we obtain the embeddings, and we put them in vector store. Vector store is just a fancy way of saying database, but these days we have some very good, interesting software that are optimized to store these numbers. But if you are good with any type of database, MongoDB, MySQL, SQLite, all would work, so as long as you know how to use them. So we store them in our vector store, and when we have a question to ask, our question is a text, a sentence of text. We need to convert that into embeddings as well. We convert it into embedding. We search for nearest matching chunks in our vector store for that relevant information, and those relevant documents are returned. Then the question, or the embedding of the question, and the relevant documents, both are fed to the language model. It can be GPT, it can be Google's PaLM, or it can be Facebook's Llama, and then it answers the question. And this all avoids the hallucination problem as well, but also for the cases, for example, if you have a private diary or any such thing, Google does not have access to it. The GPT cannot access it. But by doing this, you can build your own chatbot or search engine chatbot that responds to your natural language questions. So you can simply start asking it, and it will return to respond to your questions. So, any questions so far? I have some time, and it is a high probability that my demo might not work. Oh. So, in that case, oh, okay, it is working. Aha. But you cannot see my screen. Okay, now I want to go over some code quickly, but it is very simple. You do not need to, you only need to understand the main parts. So I am using Google Colab, and I am simply programming in Python. I promise you that you do not need any machine learning knowledge, machine learning background to start building your chatbots. And if you want to make thousands of dollars in the coming months, this is something that these are the type of projects that you will be seeing a lot on freelancing platforms as well as job descriptions. So what we do is, so LangChain, we are using LangChain library, which is sort of a, so like you have Laravel in PHP, web development framework, or Ruby on Rails for Ruby. So like web development frameworks, or in Android development, we have Android SDK. LangChain is meant to build these type of chatbots really fast. So this model comes with some basic, some really helpful methods and structure. And these are the imports. We simply copy them from their documentation. And we are using Google's Vertex AI. So which includes the PaLM language model, which we'll be using. So what we are doing is, so if you do not want me to go through the code, we can skip the coding part. But if you have questions, you can ask. So this is the essential part. What we are doing is simply using Vertex AI, Google's helper function that is part of LangChain. And Text Bison is the model that we are utilizing here. So you must have heard of GPT, GPT Turbo, GPT-4 Turbo. Text Bison is Google's model that you can integrate in your application. And so actually, this is the whole setup that is required for your application. You provided the model name, the number of tokens that you will be feeding it at once. So in our case, our sentence should be 256 words long. If it's longer, we'll divide it into smaller chunks. And temperature. Temperature can be from 0 to 1, and it controls the randomness of the output. So when you ask it a question like, what day is today? Or any other questions. So if you want it to be very deterministic or not random, you can set the temperature to 0. But if you want the model to be creative, if you are doing some creative work, content writing, or writing a script for a film, you want the temperature to be closer to 1. 0.7, 0.8 is very good. Top P, usually 0.8 is a good number, so it is the probability. So we saw when we picked the documents from the vector store, these relevant documents. So 0.8 means anything that matches 80% of the probability, bring it so that the LLM will use it to answer our questions. And top K means top 40 tokens that match this probability and then we can start running. Okay, so we create chat object from chat vertex AI, and so this is the first part. If you simply want to use integrate the, how you have been using ChatGPT, if you want to integrate it directly into your application, you simply start by questioning and answering. So in this case, we are asking it a simple question, and it responds. So let's try asking it a different question. Today is Sunday. Yesterday was Friday. So I intentionally provided it with wrong information. What is tomorrow? So Monday, let me explain. If today is Sunday, the day before Sunday was Saturday, the day after is Monday. So it is trying to correct me here that day before was Saturday actually. Let's see if it sticks with its output. Today is Sunday, yesterday was Friday. So here it did hallucinate with the information that I provided. But so that's how you can also build simple chatbots. Here are some examples we provided with the context that how we want the model to behave. So for example, if you are a nice chatbot, or we can play around. So for example, you are my assistant on a space mission. I want to travel to planet Century. Help me out. And so how many gallons of water do I need for 300 years journey? So let's try to be a bit fictional. Okay, to travel to planet Century, which is approximately 200 light years away, you would need to travel at the speed of 10% the speed of light to arrive in 300 years. To calculate the amount of water needed for a 300-year journey, we need to consider the following factors: the number of people on the spaceship, assuming a crew of 500 people. Each person would require approximately 2 liters of water per day, duration of the journey. So it did some calculation, it did some reasoning, and it came up with the answers. Anybody has any interesting input that they want to play with? We have some time to play around. Okay, so let's ask what are the ingredients? I believe this was already here. And so it also remembers the context. So we just, so here, we ask the ingredients, and here we are asking how many slices of bread you sell. So it remembers. Let's see. So the output that previously is here is from yesterday. It remembers that it had mentioned 2 slices in the previous question. But the main part is the thing that we have been building, the most sophisticated product that you can build right now with large language models is this. I'm not going to run it because so here so let's say your information is in a PDF, or it can also be from the website. You can write a basic scraper that pulls information from your favorite website if you're interested in anime, or let's say any sports, or if it is some other type of information. So you write a document loader, you import that information using the loader. The second part is we saw in our, we saw that we need to divide the document into chunks and then convert it into embeddings, store it into a vector store, and then it will be ready for retrieval. So that's what we are trying to do. So there's a loader available in the library, and we load this document from this website, and we split the text into chunks here. Very basic stuff. Everything I copied from their documentation, and then we retrieve the embeddings for these documents, and those embeddings are stored in a vector store called Chroma. You can also use any other. Chroma comes pre-configured with LangChain, so it's very easy to configure. And then we get an instance of retriever and start asking it questions. So what I did here is that I specified the URL to a book that contains jokes, and let's see if we can start asking it some jokes. Why did the scarecrow? Okay, I'm not very good at English. So let's see if there is an easier one. A man walks into a bar and orders a drink. As he sits there, he hears a high-pitched voice say, "Hey, those jeans look really great on you." The man looks around and sees nothing and returns to drink, nothing more of it. It's a long joke. Anyways, so the point I was trying to make is that, so this information is coming from the document that we specified here. And we converted that information into chunks and then embeddings using Google's PaLM language model. And this is the result. This is the first time my live demo has gone successful. So you can also control some other things, like you want to reduce the toxicity, dangerousness, violence. Yes, please.
Can I ask a question?
Sure.
Joke result, is it a joke copied from the documentation
Yes.
thread, or it generates some?
It's from the document. Yes. So the question is the document is the joke from the document, or did it know it already? So there are two types of training. So those who are interested, you can retrain the LLM itself as well on your data. But again, that has some chances of hallucination. So what is the very reliable way of building these chatbots or search engines is that you want to pair that with a vector store or a source of truth. So that avoids hallucination and you have factual information. You can also link to the document or the website from where it picked up that information, or even a PDF file from where it picked that information. Because that information, when we made these chunks, we put that information in the metadata. Yes?
What is the difference between normal database and vector one?
That is a good question. So what's the difference between a normal database and a vector store? So vector store is optimized to store numbers, especially floating point numbers, because the embeddings that we mentioned are simply arrays of long floating point numbers. So every sentence, the joke we saw in the vector store, it is represented as array of long numbers. So they are optimized for that. Normal databases are usually optimized for indexes, text strings, and other kind of input that we have. Yep.
And one more question. How we can convert that chunk into floating point?
Yes, that's this part. So LLM embedding, that's what's mentioned here. But in the we call Google's API, and we convert them to embedding. And so this is the method that is simply, so you provide it with text, and what we are doing here is that here, get embeddings for this document. That's how simple it is. And we are using Vertex AI's service. So I'll share this document. And so if you go above, we had configured our Google Cloud project. So it is actually calling Google's service and Google's PaLM model. Yes?
How about the authentication procedure for PaLM API requests?
Okay, so there is usually a quota on how many requests you can send. So it's, I believe, 5 API calls per minute on free account, so I am currently on their free tier. So 5 API calls. Any more questions? So, yeah, sure.
We couldn't much talk about the NLPs.
Mhm.
I mean, the LLMs should, we say the next level. But is it more complicated than, like, it's a new dimension?
So,
Never mentioned it,
aha. So,
not too much talk.
there is an interesting point. So, these large language models are actually the current state of the art progress that has been made in NLP domain. And the reason we didn't discuss that is that this talk was more focused on the application of LLMs, how to use them, because right now we can go into the architecture of these models, but it is extremely difficult to train them on our own. And not a lot of people are interested, so I believe only 10% would be left if I started talking about it. And these models are, for example, Facebook's Llama has, Google's PaLM, that the model that we use has 340 billion parameters, and it was trained on 50,000 GPU machines. So I worked on a startup before doing my current job, and we built an application for travelers where we rendered videos on our servers. And the GPU servers were extremely expensive. They were used by machine learning researchers and cryptocurrency miners that we have. So they are extremely expensive. So we cannot, it's really, we were paying $800 per month for a single server. And when it scales, you are usually paying tens of thousands. So it's really hard for individuals. Please.
Would it be better using the custom one instead of using premise services and make the cost effective, because you can actually train on the specialized cases and you don't have to think about any extra process? So basically, the question is kind of like, is the hosting yourself in the cloud is better than using an API key, but at the same time you are thinking about cost effectiveness. Would it be possible in your ends? Just kind of another point of view on this ask.
Yeah, that is a good question. So what you can do is, what you can do is, instead of making API calls, you can replace in your this large language model that you are using. Instead of using Google's model, you can use Facebook's open sourced Llama model. But then you will have to deal with making the infrastructure available for, like I mentioned, GPUs, and making sure that it's fast, optimized for your calls. So yes, that is, but it comes with a bit of a headache. So you should have some engineers. Yeah.
I just say I take the risk.
Yeah.
The job is it going to be effective? Because what I'm thinking is, okay, there's a risk management. I understand assessment we have to do. Yes, I can use the PaLM and go with my own very, very easy. I get it, but using a custom way wouldn't be making it much optimized and faster. Because the cause is right now, it's more, let's say, data, but I want a much more reliable result. That's the kind of the perspective. I don't know.
Yep. So that's definitely doable. So this architecture is completely, this has evolved organically. So this is not by Google. So you can pick and choose any part. This vector store, the language model.
By the way, which database you prefer to use?
I myself, so far I have only used Chroma, which is very specific, but you can use Redis and Postgres have very good support. They are already really fast. So, yeah.
I was thinking about more than Superbase maybe you use for.
Superbase?
Yeah.
So I have experience with Superbase, but I haven't used it for vector store.
Yeah, I think you use Chrome more than any other tool.
Okay. Okay. Thank you, everyone. If you want to connect, please connect with me on LinkedIn. And that's all.